Hello everyone. In today's class, we're going to discuss about testing the behavior of sequence and also to write the Maxima codes for testing the behavior of a sequence. Now, before starting with that, let's recall what is meant by limit of a sequence. A sequence is said to tend to a limit L if for every small epsilon, which is positive, there exists a positive integer m such that the distance between the nth term and limit L is less than epsilon whenever n is greater than or equal to m. And this is symbolically denoted by limit as n tends to infinity, xn is equal to L. Remember, your xn is the nth term of the sequence. So when you apply the limit for nth term as n tends to infinity, you're going to get L. Now, when will you say a sequence is convergent? We say a sequence is convergent provided there exists a finite and unique limit L as n tends to infinity. So, if the limit of the sequence is finite and unique, then the sequence is convergent. If the limit of the sequence is plus infinity or minus infinity as n tends to infinity, then the sequence is said to be divergent. And what is meant by oscillatory sequence? A sequence is said to be oscillatory if the limit is not unique or plus infinity or minus infinity. That means it oscillates between two values. So if the limit of the sequence oscillates between two values, then the sequence is said to be oscillatory. Now let's solve some examples and also write the Maxima codes for testing the behavior of the sequences. The first sequence which we are given is 1 plus 1 by n. So here nth term is 1 plus 1 by n. Let's call that one as xn. So we have to find the limit of this nth term. So let's apply limit as n tends to infinity of this. When you apply limit as n tends to infinity, simply you will get this. And this is 1 plus 0, which is equal to 1. Therefore, the limit of the nth term of the given sequence is finite and unique. Hence, the given sequence is convergent. Let's write a Maxima program for this. Okay, as usual, we start with kill all. Just to kill all the values assigned to the variables. Then, nth term of the sequence is 1 plus 1 by n. We'll assign that. xn is the nth term which is assigned with 1 plus 1 by n. And variable in the nth term is n. So let's call var is assigned with n. Add given var, you can give anything. And print, I just want to print the sequence. So print the given sequence is, what is your given sequence? Just print the nth term of the sequence, that's it. Now, after this, we want to find the limit of nth term as n tends to infinity. So, I'll assign that one as L. L is assigned with limit of nth term xn for variable going to infinity, that is INF. Nth term variable infinity. If you give this, then it calculates the limit of the limit of xn as n tends to infinity, and that will be stored in L. So once after calculating that, I want to print it. So print limit of the sequence is L. Now so we got the limit. Now I just want to verify whether the given sequence is convergent, divergent or oscillatory. So to check the behavior, we'll consider if absolute value of L is equal to infinity. So when you put absolute value, you don't have to worry about plus infinity or minus infinity. So you don't have to worry about signs. So if absolute value of limit is equal to infinity, then by the definition you know that that sequence is divergent. If this is true, if absolute value of L is equal to infinity, then print the given sequence is divergent. Else if, this is one word, else if this is not true, then check absolute value of L is not equal to infinity and absolute value of L is not equal to indeterminate. You should not get indeterminate also. Then obviously the given sequence is convergent. Print the given sequence is convergent. If absolute value of L is equal to infinity is not true and this is also not true, then else print the given sequence is divergent. For the last one, you don't have to write else if, because there is no need of the condition. This is the last choice which we left out with. This is oscillatory, not divergent. This should be oscillatory. The last option is oscillatory. Print the given sequence is oscillatory. If these two are not true, then we left out with the last option, that is the given sequence is oscillatory. That's why I've used else statement. So else print the given sequence is oscillatory. Then you put shift enter, that gives you the output. So this is how you have to write the Maxima code. Okay, let's see the next example. And given another example, log of n plus 1 minus log n whole divided by sine of 1 by n. Now let's call this one as nth term. So xn is log of n plus 1 minus log n whole divided by this. Now if you apply the limit, you're going to get indeterminate. So let's simplify this so that I can use the standard limit results which we are having, and I can get the answer. So I've simplified this. First I've applied log m minus log n formula so that this becomes log of n plus 1 by n, and I've divided each term of this by denominator, so n divided by n is 1 plus 1 divided by n. Then multiplied and divide this by n. If you cancel these two, you'll get the old answer. Then I've sent this one using the log property to inside, so I can write this one as log of 1 plus 1 by n whole to the power of n, and I've sent n to n denominator so that this becomes 1 by n, sine 1 by n divided by 1 by n. If you send 1 by n to numerator, that becomes n only. Now after this simplification, I'm applying the limit as n tends to infinity xn, which is equal to limit of this term. But we know that by the properties of limit, we can apply the limit for numerator separately and denominator separately. So limit as n tends to infinity log of this divided by limit as n tends to infinity this. And we know that because this is a continuous function, so I can interchange log. If you interchange log and limit, this is Riemann integrable, so I can interchange them. So I can write this one as log of limit as n tends to infinity 1 plus 1 by n whole to the power of n, and limit of this. See, limit as n tends to infinity is also same as 1 by n tends to 0. Why? If you cross multiply, you'll get n here. This is 1 by 0, so that is infinity. So when n equal to infinity, 1 by n will be equal to 0. Because of that, I can write, instead of simply n tends to infinity, 1 by n tends to 0. So limit as 1 by n tends to 0, sine of 1 by n by n, 1 by n. Now see, this is a standard result. Limit as n tends to infinity 1 plus 1 by n whole to the power of n. The answer is E. So that is what I have written. Right? And this is of the form limit as theta tends to 0 sine theta by theta. So that is also 1, and log E base E is 1. So 1 by 1 is 1. So we got limit of this sequence as 1, which is finite and unique. Hence the given sequence is convergent. Now writing the Maxima program is same. Just you need to change the nth term. That's it. remaining thing is one and the same. Now let's move on to one more problem. The nth term of this problem is minus 1 to the power of n divided by n. So nth term of this sequence is this. Now here, let me apply the limit. So that limit as n tends to infinity, minus 1 to the power of n divided by n. Here, depending on the value of n, that is whether n is odd or even, this takes two values. For all, when n is odd, for all those values, odd number, your minus 1 to the power of odd number will be a minus 1. So this becomes simply limit as n tends to infinity minus 1 by n. And when n is even, minus 1 to the power of even number will be 1. So simply this becomes limit as n tends to infinity 1 by n. Now apply the limit. When n equal to infinity, simply you will get minus 1 by infinity. But 1 by infinity is 0. And when n equal to infinity, this also becomes 1 by infinity. So in both the case we are getting 0. Therefore in all the case, limit tends to 0 only. Therefore 0 is a finite and unique limit. Hence the given sequence is convergent sequence. And writing the Maxima code is same. Only thing you need to change the nth term. Minus 1 cap n. That gives you minus 1 to the power of n whole divided by n. And variable is n. Print the given sequence is xn. And find the limit and print and check whether the limit is infinity or it is not equal to infinity and indeterminate. Then obviously it will be oscillatory if these two are not true. That is what the condition you need to write. Now let's see the next example. In the next one, the nth term of the sequence is 1 plus minus 1 to the power of n. So this is your xn. Now let's apply the limit for this. Limit as n tends to infinity 1 plus minus 1 to the power of n. Now remember, when n is odd, this takes different value. When n is even, this takes different value. Because when n is odd, minus 1 to the power of odd number is minus 1. When n is even, minus 1 to the power of even is 1. So you are having two limits depending on the choice of n. Now 1 plus minus 1, this gives you 0. So what is limit of 0? There is no n at all. Simply you will get 0 only. What is the limit of 2? There is no n to apply the limit. The limit of a constant term is same, 2. So here we are getting two values depending on the n. Therefore this limit is not unique, but it oscillates between two values. Therefore the given sequence is, yes, oscillatory sequence. For this also, writing the program, that is Maxima code, is same. 1 plus minus 1 cap n. And remaining things same. Then see the next one. Here the nth term is minus n square. Now when you apply the limit, I don't have any choice. Straight away I have to apply the limit. You will get minus infinity square. Infinity square is infinity. So simply you will get minus infinity, which is not finite, but it is infinite. Therefore the given sequence is divergent sequence. Writing the program is one and the same. After this I had given some elementary problems. You solve them and also write the Maxima code. And let's execute now this using Maxima. Now let us read the Maxima program. As usual, we'll start with kill all. So kill all. Then afterwards we'll assign the nth term. What was our nth term? 1 plus, I'll write within bracket 1 divided by n. I don't want to display this, so simply I'll put a dollar sign. Then I have to assign variable. What was our variable? It is n. I don't want to display this, simply put $sign. Then I want to print the sequence, print the given sequences. Everything has to come within the double quote, so that this will not be executed. When you write within double quote, that is simply non-executable statements. Then put a comma. So which is your sequence? Yeah, nth term of the sequence will be displayed, and I'll put a $, because already this is displaying. Now let me calculate the limit. So I'll give capital L, because small l and 1 look same, so I just don't want to get confused with that. So I had given capital L, limit, what is your nth term? Xn, and your variable is var, it's stored in var, and where it has to go? It has to go up to infinity. So this calculates limit, and that limit will be stored in L. Now I want to display this limit. Print the limit of the given sequence is, put a colon, and you have to write this one within apostrophe, double apostrophe, so that that will be displayed as it is, and the answer is stored in L, so I have to give L. Then now I want to test the behavior of the sequence. So if absolute value of L, that is limit, is equal to infinity, then it has to print the given sequence is divergent. Since I'm having three conditions, I have to use else if absolute value of limit is not equal to infinity and absolute value of L, these are must, that's why I'm using AND, right, is not equal to indeterminate, then print or display, print the given, print the given sequence is convergent, right? Then if these two are failing, in that case I need to give else, the last option. What is that? Print the given sequence is oscillatory. I'll end this if else statement with a $sign. Now let's execute this using shift enter. See, the given sequence is 1 plus 1 by n, nth term of the sequence, and limit of the given sequence is 1, which is finite and unique, therefore the given sequence is convergent. Let me write this one as the nth term of given sequences. Yeah. Now let's write one more program for divergent sequence. Let's say it is minus n square, minus n cap 2. Everything is same except the nth term. Now let's test the Maxima code using shift enter. See, minus n square, the limit of the sequence is minus infinity, therefore the given sequence is divergent. Let's write one more program for oscillatory, and let me give 1 plus minus 1 cap n, right? Remaining program is same, just I have to change the nth term. Press shift enter. See, we got this is indeterminate. It's not possible to find the limit because it is not unique. Therefore, the given sequence is oscillatory. So this is how you have to write the Maxima code and get the output. Thank you.